In Unit 3, there are two important derivations. One is EOQ, economic ordering quantity derivation, also known as purchase model. Next, coming to the second derivation, manufacturing model, also known as production model, also known as EBQ. What do you mean by EBQ? What is the expanded form of EBQ? EBQ means economic batch quantity. EBQ means economic batch quantity. Particularly, this model is applicable to batch type of production. Everybody knows that. What do you mean by batch production? Batch type of production. In Unit 1, we have already studied. In batch type of production, the product is produced in lots or batches instead of continuous production. Sometimes we can stop manufacturing operations. In some other time we can start the manufacturing operations. Starting and stopping. Starting and stopping manufacturing operations. So this type of production is also known as intermediate production. Most of the modern scale organizations follows this type of batch type of production. By using this type of batch production, we can produce different variety of products but limited in number. In this production, one of the important remembering point is batch production is suitable where the production rate is more than consumption rate. Production rate is more than consumption rate. From this statement, we can observe that every time stock is available, stock of items is available. There is no question of shortage because production rate is more than consumption rate. So how to derive this EBQ formula? To derive this formula, first of all, mention some assumptions. Write some assumptions. What are the assumptions involved in this model? Assumptions. First assumption is annual demand. Say in first model we have already discussed. In model 1 we have already discussed annual demand is uniform, known and is constant. Okay, this is same dialogue in model 1 also same dialogue. Next, coming to the second assumption, cost per unit is same. Cost per unit is same. That means quantity discounts are not allowed. Cost per unit is same. Third assumption, here instead of ordering cost, setup cost is incurred. Setup cost is involved. Setup cost. C suffix S means setup cost. Setup cost is the same in every setup. Under batch production, sometime we can stop the manufacturing operations, some other time we can start the manufacturing operations. Start to stop. In each time, we are incurring some amount of money, known as setup cost. For changing layouts, we are spending some amount of money. That money is constant, same every time. In real situations, that is not possible. This is the ideal case. So, setup cost is same in every setup. Instead of ordering cost, we are mentioning setup cost. This is the case of, in the case of production, in the case of manufacturing model. Manufacturing model. Okay. Write some assumptions. In second model, that means EOQ model or production model or manufacturing model, you have to draw this diagram. How to remember this diagram? It's look like a saw teeth. Derivation 1 diagram looks like a right angle triangle. This diagram looks like a sawtooth form. Okay, first I will explain about this diagram. From this diagram we can observe that on x-axis we have considered time. Time may be represented in years. On y-axis we have considered quantity produced or manufactured. Because this model is a manufacturing model. That's why we have to change the sentence terminology. Quantity not ordered, produced. Quantity produced. Here product is produced in lots of batches. First consider one cycle. One cycle. This is one cycle. This is one cycle. Here one more assumption is no shortages are allowed. Only stock is allowed. Shortage means this graph falls below this diagram, zero line, below zero diagram, below zero. So there is no question of that stock outs. Always stock is there. At this point, we are starting the manufacturing operations to produce some product. The product may be related to batch type of product. Okay. Here the product is producing with some production rate. This line indicates production rate. P. P means where, small p means, these are the new terms in this derivation. P means production rate, number of units produced per unit of time, linked with time. Okay. Small p means production rate. Next. P minus D means P minus D. First of all, I would like to explain about small d. Small d means consumption rate. We are producing, at the same time we are consuming that produced item. Consume is also there in the same time. So D means consumption rate. One condition in this model is production rate should be greater than consumption rate. P should be greater than D. Okay. Therefore, this consumption rate is less consumption rate. Let us assume D is the consumption. After some particular period of time known as T suffix P. What do you mean by T suffix P? It is nothing but the production time. TP is the production time. Up to TP time, the production continues. Here stock buildups, that means quantity builds up at the rate of P minus D. P minus D is nothing but the growth rate, stock growth rate. This stock growth rate is less than this production rate. P minus D slope is less slope when compared with the small p line. Growth rate. After reaching certain level, this level is known as economic batch quantity level. Let us assume as Q star. Economic batch quantity. After reaching certain level, so this level is known as Q star, known as economic batch quantity. Q star means economic batch quantity. Production stops. So production continues up to TP. After that, production stops. After reaching the optimum stock level, production stops. Next, only consumption is there. Consumption. What is the consumption rate? Small d. Small d is the consumption rate. Our stock produced items will be reduced like this, depending upon the time. So TD, one more new time, TD. What do you mean by TD? Depletion time. Depletion. Our produced stock will be depleted. Therefore, that corresponding time is known as depletion time. During depletion time TD, our produced stock will be over. At a certain instant of time, maybe it may reach to this level, 0 level. Again, what we are going to do? Again, start the manufacturing operation. Same cycle will be repeated here also. So, like this, these cycles will be continued in the year, in the 1 year. So first understand one cycle, then you can expect same concept for other cycles. Once again, I would like to revise all these things. Small p is the production rate, small d is the consumption rate, p minus d is nothing but the growth rate. In this model, production rate should be greater than consumption rate. On x-axis we have considered time, y-axis we have considered quantity produced, not ordered, because it is a manufacturing model. TP is the production time, TD is the depletion time. Here we are starting the manufacturing operations with a production rate of small p. At the same time, we are utilizing our produced items. Therefore, growth rate is somewhat less slow. Therefore, our stock reached with a rate of P minus the growth rate. Once it reaches optimum production quantity known as Q star, we can stop the manufacturing operations. So then only consumption is there, that is also uniform with a rate of small d of the produced items. Stock reduces like this. So during T, therefore T suffix D is nothing but the depletion time. Capital T means it is a cycle time. Cycle time is nothing but the production time and depletion time. Okay? From this diagram, we are going to derive average inventory level. Average inventory level. Next coming to the symbols used in this derivation, because different books may give different notations. That's why clearly I am defining all the symbols used in this derivation. For this economic batch quantity model derivation, I used these symbols. Most of the symbols are common in model 1 and 2. Please observe. First symbol capital D, as usual, annual consumption or annual demand. That means number of units demanded in a year is capital D. Next, second symbol small p indicates production rate, number of units produced in a unit of time. Similarly, small d is nothing but the consumption rate, number of units consumed in a unit of time. What is the difference between capital D and small d? Capital D means must and should, demand should be represented per year, whereas in case of small d, demand per unit of time. Unit of time may be days, it may be months, it may be weeks. This is the difference. Consumption rate. Next symbol capital C means cost per unit represented in rupees. I value carrying cost represented in percentage, and CC carrying cost, it is expressed as rupees per unit per year. Also multiplied with C with I, we will get CC. CC is equal to C into I. Always you can remember this formula. And one more symbol is new symbol CS. CS means setup cost. In place of CO, in case of model 1, we have seen CO. CO means ordering cost. This is model 2. Model 2 comes under production model or manufacturing model. In this model, we cannot observe any CO, only CS. Setup cost in each setup is same. You can correct that sentence. Setup cost represented rupees per setup. Instead, order is wrong. As usual, capital Q indicates economic batch quantity. Same symbol I have considered. In production model, Q is called as economic batch quantity. In purchase model, Q is called as economic ordering quantity. That is a change. Please notice this change. Please observe. Okay. To derive EBQ formula, first of all, I would like to explain about each term. First term is the T suffix P, means production time. T suffix D means depletion time. From the previous diagram, we can observe that during the period TP, that means production time, inventory, that means stock, builds up at the rate of P minus D. Already told, P minus D is nothing but the growth rate or inventory build-up rate. Units per unit of time. After time TP, inventory depletes at the rate of small d. Therefore, formula for production time is, in model 1, you have already seen small t is equal to cycle time, which is nothing but the Q by D, where Q means economic ordering quantity. In model 1, Q means economic order quantity, D means annual demand. Q by D is nothing but the cycle time or time between the orders. In the similar way, TP is nothing but the production time. Here Q means economic batch quantity. In this case, Q means economic batch quantity. Here Q means economic batch quantity. In place of D, simply substitute small p. Small p means production rate. So production time is equal to economic batch quantity Q divided by production rate, small p. Next, we are going to calculate maximum inventory level, also known as maximum on hand inventory. Maximum inventory level. After calculating maximum inventory level, we are going to calculate average inventory level. Ultimately, we are going to write the equation for average inventory level. First of all, maximum inventory level or maximum on hand inventory. It is nothing but the during production time, production will be taking place at the rate of TP. TP is the production time into during that time stock will grow at a rate of P minus D. P minus D is nothing but the growth rate, stock growth rate. Okay, that is equal to, in place of TP, substitute these values. Therefore, Q by P into P minus D. P minus D. Now, we can also write this equation as P minus D by P. Okay. This is also written as P by P means 1, D by P. So this is the maximum inventory level. Q into 1 minus D by P is nothing but the maximum on hand or maximum inventory level. Next, average inventory level. Average. How to write average inventory level? Average is equal to maximum inventory level plus minimum inventory level divided by 2. 1 by 2 I am taking outside. Maximum plus minimum. Maximum plus minimum divided by 2 is equal to 1 by 2 into maximum is Q into 1 minus D by P. Minimum is 0. At the end of the cycle, you can observe 0. minimum level is 0. Maximum plus minimum divided by 2. And finally, we will get average inventory level is equal to half into Q into 1 minus D by P. This is the average inventory level. Okay, this is important one. Okay, next, how to derive this EBQ formula? To derive this EBQ formula, there are two methods. One is the graphical method, second one is the calculus method. So in this model, we can see calculus model. In calculus model, first of all, calculate total cost. Total cost. Already told, total cost means total carrying cost and total setup cost. Total setup cost in EVQ model. One by one I would like to discuss. First, total setup cost. Total setup cost means number of setups in a year into average inventory level. Average inventory. First, we are going to calculate total cost. Total cost means total setup cost and total carrying cost. What do you mean by total setup cost? Total setup cost is equal to number of setups in a year, into setup cost in each setup, known as CS. Number of setups in a year means what is the demand or annual demand, capital D. In a 1 year, demand for the item is D. Each time, how much quantity we are producing, economic batch quantity represented as capital Q. D by Q is nothing but the number of setups in a year into the cost in each setup is CS. D by Q into CS is nothing but the total setup cost. Okay. Next, coming to the second cost, total carrying cost. Total carrying cost. Total carrying cost is nothing but the average stock level or average inventory into carrying cost per unit per year. CC. Average inventory we have already determined, that is Q by 2 into 1 minus D by P into CC. This is equation number 2. This is equation number 2. Total cost is nothing but the equation 1 plus equation 2. Total cost is nothing but the equation 1 plus equation 2. This is TC. So, to find out the economic batch quantity known as Q, Q is the variable. Q is the variable. We have to differentiate total cost with respect to variable. That means Q is the variable. D by dq of TC is equated to 0. Then what will happen? what will happen? D by dq, TC means total cost, means D by Q into CS plus Q by 2 into 1 minus D by P into C is equal to 0. Is equal to 0. Here annual demand is constant, CS is also constant, take it outside. So D into CS, take it outside. D by dq of 1 by Q plus D by dq of Q means 1, so 1 by 2. Here small d, small p are the constants because production rate, consumption rate, take it outside, into CC is also carrying cost, constant, is equal to 0. This implies the D into CS, D by dx of 1 by x, that means minus 1 by x square, is 1 by Q square, plus 1 by 2, 1 minus P by, D by P, not P by D. Okay, after adjustment, Q square is equal to 2 into D into CS divided by 1 minus D by P, Q minus 1 minus D by P. This you will get. Finally, economic batch quantity Q is equal to, Q is a subject, 2 into D into CS by CC into 1 minus D by P. This is under square root. So this is the final equation known as economic batch quantity in case of production model. Okay, this is the second important derivation in unit 3. Okay, finally EBQ formula is Q star means optimum batch quantity is equal to square root of 2 into D into CS, where CS is the setup cost, divided by CC into 1 minus small d divided by small p. This is under square root, where small d is the consumption rate, small p is the production rate, CS is the setup cost. D and CC are the same, annual demand as well as carrying cost per unit per year. Okay, this is very important formula. This is the second derivation. Only two derivations. One is EOQ model, second one is the EBQ model. Okay, so in model 1, that means economic order quantity model, formulas to be remembered to solve problems, any type of problems. Formulas to be remembered. First formula, economic ordering quantity, usually represented as capital Q, is equal to square root of 2 into D into C naught divided by CC. Everybody knows that D is the annual demand, C naught is the ordering cost, CC is the carrying cost. This is the first formula. Next to second important formula, number of orders placed in a year. In shortcut we can call it as capital N. Capital N is equal to D by Q, where D means annual demand or annual consumption. Both are same. Q is the economic ordering quantity. This is nothing but the number of orders. Next, third important formula, small t. Small t means time between the orders. Time between the orders. It is the reciprocal of number of orders, or capital Q by capital D. What is the time unit? Always time unit must be represented in years, because here D is nothing but the annual demand. Annual means per year. So time unit becomes years. Next, fourth important formula, optimum or optimal cost. Optimal cost means only on inventory cost. Shortcut we can call it as a C minimum, only on inventory. That is Q by 2 into CC. It is nothing but the total carrying cost, total annual carrying cost. Second one is the ordering cost. D by Q is nothing but the number of orders placed in a year into ordering cost per order. This is the optimum cost. Next, fifth formula, total cost, TC, including material cost. What is the difference between C minimum and TC minimum? C minimum is only on inventory. TC means total cost. It includes total material cost also. So therefore we have to add total material cost. How we can represent? With the help of symbols. C is the cost per unit, D is the annual demand. C into D is nothing but the total material cost plus this optimum cost. That means C minimum. Welcome to all. In the previous class, we have derived an equation for simple EOQ model known as Wilson-Harris formula, also known as purchase model. So in this class, we are going to solve different variety of problems on inventory. First model is a EOQ model, also known as purchase model. First question, compute EOQ and variable cost for the item having annual demand of 5,000 units. 5,000 units. From this data, we can observe that first write down the given data. Given data. First read the problem carefully, 1 or 2 times. Try to write down the given data. Compute EOQ and variable cost for the item having annual demand of 5,000. That means annual demand is given. Annual demand means number of units consumed in a year is nothing but the annual demand. Already assumed that symbol is known as the capital D. Capital D is nothing but the annual demand is equal to 5000 units. 5000 units per year. Okay, demand is given. Next, unit price of 20 rupees per item. Unit price means cost per unit represented as capital C is equal to 20 rupees. 20 rupees. 20 rupees per item. Okay. Next, ordering cost at 16 rupees per order. Ordering cost. What is the symbol used? C suffix O. CO is nothing but the ordering cost. That value is given as 16 rupees per order. Okay. Next, storage rate at 2% per annum. Storage rate. So for storing of some unit item in a year, how much percentage we are consuming, we are incurring, how much percentage we are incurring? 2% storage purpose. Similarly, interest rate at 12% per annum. Obsolescence rate at 6% per annum. Therefore, all are represented in percentage. That means holding cost or inventory carrying cost represented as I. I is, what is meant by I? I means inventory carrying cost or holding cost represented in percentage. So you can simply add all the three percentages. That means 2 plus storage percentage per year, 2% interest rate per year, 12% plus obsolescence rate. All are comes under carrying cost. All are comes under carrying cost. That is 6%, 6% per annum. So total is 2 plus 12, 14, 14 plus 6, 20. This is percentage. Percentage. So percentage 20% means how much? 20 divided by 100. 0, 0 cancel. 2 by 10 means 0.2. I value is given as 0.2. Okay. Next, what is our objective in this problem? Compute EOQ. EOQ, what is the formula for EOQ? In the previous class I have listed out all the formulas used in model 1. EOQ, what is meant by EOQ? EOQ is nothing but the economic ordering quantity. Economic ordering quantity represented by the symbol capital Q. Capital Q. Very, very important formula. This is under square root 2 into D into C naught divided by CC. CC. This is the formula used to find out EOQ. Here D value is given. C naught value is given. CC value is not given. CC value is not given. How to find out CC value? CC is equal to C into I. C into I. Where C is the cost per unit, I is the inventory carrying cost or holding cost represented in percentage. Therefore, C value is equal to 20. I means 0.2. 20 into 0.2. That means 20 into 2 by 10. 0, 0 gets cancelled. Rupees 4. per unit per year. 4 rupees per unit per year. What is the physical meaning of CC, carrying cost? To carry 1 unit of item in the storeroom for the year, for 1 year. How much cost we are incurring? 4 rupees on each unit. This is CC. Now we can simply substitute all these values in this equation. You will get Q value. That value is, it will come 200 units. 200 units. 2 into B 5000, C naught 16 divided by CC means 4. This is under square root. 2 times 2500. 2500 square root 50. 16 square root 4. 50 into 4, 200. Therefore, economic order quantity is equal to 200 units. That means we have to place an order of 200 units. Then only cost will be reduced. Which cost? Total inventory costs. Inventory costs are classified into 2 categories. One is carrying cost, second one is the ordering cost. Next, second question, compute variable cost. Variable cost. Variable cost. What do you mean by variable cost? Variable cost is nothing but the optimum inventory cost. Symbolically, you can denote like this. C minimum is equal to total carrying cost. We know that Q by 2 into CC plus D by Q into C naught. Q by 2 into CC is nothing but the total carrying cost. Similarly, D by Q into C naught is nothing but the total ordering cost. Therefore, Q value we know 200 divided by 2 into CC. CC already 4 plus D by Q. What is the value of D? 5000 divided by Q value 200 into C naught. C naught means 16. 200 by 2 means 100. 100 into 4, 400 plus 0 0 cancel, 0 0 cancel. 8 2s are 16. 8 5s 40. That means 400. 400 plus 400. This is in rupees because cost is represented in rupees. Therefore, 800 rupees. This is the optimum inventory cost. From this problem, you can observe that EOQ is obtained where total carrying cost is equal to total ordering cost. Now you can observe from this problem what is the total carrying cost? 400. What is the total ordering cost? 400. 400. Both are 400. Final optimum inventory cost is 800. This is the answer. This is Q is equal to 200. C minimum is equal to 800. Next we are going to enter into the second problem. Next, to move to the second problem. A company has an annual demand of 5,000 units. From this statement, we can observe that annual demand is given, represented by the symbol capital D. So, therefore, given data. Capital D value is given as 5,000 units per year. Annual means per year. Next, the ordering cost is 250 rupees per order. This is represented in rupees per order. Okay. The price of a unit is, price means cost price, capital C is equal to 100 rupees. 100. The holding cost is here 10%. Already told, if he gives percentage means you can assume that value as I value. If it is represented in rupees means CC carrying cost. Therefore, here I value is 10%. 10% is equal to 0.1 because 10 by 100. 10 by 100 is nothing but the 0.1. Okay. Find the EOQ. Very easy. We know that economic order quantity denoted by the symbol capital Q. This is under square root 2 into D into C naught divided by CC. Directly, CC value is not given. CC value is not given. Therefore, calculate CC. CC is equal to C into I. C into I. From this, you can calculate CC. We know D value, we know C naught, we know CC. Finally, it becomes, Q becomes 500 units. 500 units. Economic order quantity is the 500 units. This is optimum order quantity. And also calculate total cost. What is the formula for total cost? Total cost is equal to total material cost, capital C into D is nothing but the total material cost in a year, plus total carrying cost Q by 2 into CC, plus total ordering cost D by Q into C naught. D by Q into C naught. This is the total cost formula. Simply substitute all the given values. You will get $5 lakhs 5,000. 5 lakhs 5,000. This is the total cost. Next, some more information is there. That is, if the EOQ increases by 10%, that means this is special case. This is special case. What is that value is given? If the EOQ increases by 10%, that means Q dash means new EOQ, new economic ordering quantity. Q dash is equal to increases 100 plus 10. Increases means plus, decreases means minus. How much percentage is increasing? 10%. Therefore 100 plus 10 by 100. This is increasing factor on original economic order quantity, that means Q. Therefore 110 divided by 100, that means 1.1 into Q. Q dash is equal to 1.1 into Q. This is the logic involved in this problem. If the EOQ increases by 10% means new EOQ, that is Q dash, is equal to 1.1 into Q. Next process becomes easy. Q dash is equal to 1.1 into Q already knows, that is 500. So 1.1 into 500 is nothing but the 550 units. 550 units. So in the second case, Q dash economic order quantity is 550. So in this case, calculate total cost. So calculate total cost at that quantity. That means at Q dash. Therefore TC dash, or let us assume TC dash, Q dash is equal to, we know the formula, that is C into D plus, this is total material cost, plus total carrying cost, Q by, in place of Q, simply substitute Q dash. Q dash divided by 2 into CC plus D by Q dash. That means number of orders placed in a year, nothing but the D by Q, into ordering cost in each order is fixed and constant, CO. So after substitution of all the values, you will get, so this is the answer for total cost at Q dash. Therefore what we are going to determine, finally we are going to determine the change in total cost. Therefore change in total cost is equal to, earlier we got this cost. Now when the quantity changes means now cost becomes this. This is the highest value, this is lowest value. The difference between these two costs is nothing but the change in total cost. The difference between TC dash and TC is nothing but the change in total cost, is equal to 22.7. This is expressed in rupees. This is the change in total cost.